All right, guys, today's objective is 4.5. We are halfway through the meat of this unit. And today's topic is the greatest integer function. So you will be successful when you can recognize the notation for greatest integer. You can explain what greatest integer means. And you can graph a basic greatest integer function. So what I have over here in the left-hand column of my notes is the definition of integer, because I was finding out as I was going along today that that's not something we are confident we remember. So in the left-hand column of your notes, I will put this on the quiz, the definition of integer. You will have to define it. So I say study it, put on your note page, study it, memorize it, know it. An integer is a whole number or a negative whole number. If it's considered an integer, it does not have a part of a number, doesn't have a fraction of a number, doesn't have a decimal portion of a number. An integer's definition is that it is a whole number or a negative whole number. This right here is an acceptable definition of integers because it's the set of ellipse, -2, -1, 0, 1, 2, ellipse, telling that it goes forever in both directions. Those are integers. Okay? All right. So I wanted to talk about that. The other thing I wanted to talk to you about is that a greatest integer function is a discontinuous function. The graph will have breaks in it. In fact, another word for a greatest integer function is a step function. And I'm going to show you what that means right now. So what I have here in my graphing calculator, let me turn some things off here. Okay, so in my screen, I think you guys can see everything with my recorder where it is. Okay, so right now I have in my graphing calculator 6 different equations typed in. And right now I have equation 4 and 5 turned on. I'm going to turn them off. To do that, first I'm going to turn equation 1 on. So to do that, I'm going to arrow right on top of the arrow, hit enter, and it's going to select that graph. I'm going to show you what it looks like. And then I'm going to come down here to equation 4, hit enter, turn it off, and equation 5, hit enter, turn it off. Okay, so I'm going to graph it so you can see what you're going to be asked to do today. This is the graph of y equals the greatest integer, x. Can you see why we call it a step function? Yeah, the graph steps. Isn't that interesting? It steps. Now, what I'm going to do now is I'm going to show you the table of values that represents this graph. So to do that, I'm just going to select the second function of the graphing function button here. And you can see that all of my y numbers, my outputs, are all integers. There are no fractions. There are no decimals. Well, my input in my x's, you can see that I have whole numbers and half numbers. I can put pretty much any number I can put any number I want into a greatest integer for x. I can input anything I want. But the only thing I can get out of a greatest integer function is an integer. So my output is always going to be a whole number or a negative whole number. So what I'm going to do is I'm going to let you pick any x you want. So I'm going to choose value, and I'm going to calculate a value. And you can pick any x that you want. Keep it reasonable so, we're not typing forever. Let's not make it a whole number. You can test. Just say one. 2.58. 2.58. Let me see if I can see the points here. 0.58. And hit enter. Look at what my y is. 2. Okay, so I plugged in a 2.58 and it rounded it down to a 2. I didn't round it up to a 3. Isn't 2.58 closer to 3? So there must be something to the definition of a greatest integer. Question. 0.01. Okay, so let me grab my value again. I'm going to type in a 0.01. Enter. 0. Interest. That it doesn't matter what kind of number I input, I always get out an integer, a whole number. Okay, so let's take a look at a couple of other graphs. So I'm going to go back to my graphing where I input my equations, and I'm going to highlight equation 2. I'm going to leave equation 1 on, and I'm going to turn on equation 2. Okay, so the first one says y equals the integer, the greatest integer of x, and the second one says y equals the greatest integer of half x. Does anybody have a prediction what they think is going to happen to my graph? Not as steep. Okay, so there's a guess. It's not as steep. Anything else? Okay, well, let's see what happens. It's first going to graph the blue one, and then it's going to graph a red one because the second equation's in red. So let's take a look at that. The blue one's graph. Here comes equation 2. Look at the steps. There's not as many. There probably is as many because they go to infinity, but they're longer. They're twice as long. This right here, look how long it is. 2. Well, that's interesting. So if the number inside your greatest integer on your x is a fraction that's less than 1, it made your step longer. So what do you think would happen if I go to my third equation, which says the greatest integer of 3x? What do you think it's going to do? You think it's going to get even longer? Okay, Eric says shorter. Let's vote. How many of you think it's going to get longer? How many think it's going to get shorter? Okay, let's see who's right. I like it. Good thinking. Okay, let's graph it. Oh, did I turn it off? No, I turned it on. Okay, here we go. Here it comes. It's black. Oh, look at those little skinny steps. Made it smaller. Made it really smaller. Okay. Excuse me. So that all has to do with what happens when I put a number with the x as the coefficient of x. What changes the length? It changes the length of your step. It either will stretch it horizontally or it'll compress it and squeeze it in and make it short. Okay, so what I'm going to do now is I'm going back to my equations, and I'm going to leave equation 1 on because it's the one I'm going to compare everything to. I'm going to turn off 2 and turn off 3, and I'm going to turn on equation 4 that says 2 times the integer of x. Vote. What do you think is going to happen to my graph? Things go opposite direction? Okay, that's a guess. What else? What do you think back there, Andrew? Okay, so you think it's going to skip 2 some way? Do you think it's going to skip 2 up and down or skip 2 left and right? What do you think? Left to right. Okay, well, let's see what happens. Okay, so here's the parent function. Nothing on it. It's just the greatest integer of x. See the purple? They're further apart. See, the blue one, they're the same length. See that? Steps are the same length. You can see it right here because they graphed right on top of each other. So they both have the same length. But instead of the blue where it goes over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, the pink ones go over 1, up 2, over 1, up 2, slide over 1, up 2. See it? So it's going to stretch your graph vertically. So it's going to make the steps between them more dramatic. All right, so I'm going to go back to my graph and we're going to look at one more. So I'm going to leave that one. I'm going to turn this one off. So that's our parent function. I'm going to take that and turn it off. I'm going to come down here and turn on equation 5. Maybe, if it'll cooperate. Something just happened. Everything just shut down. Man, I was in the middle of something good. Okay, so I have equation 4 and 5 highlighted. The top equation 4 says 2 times the greatest integer of x, and the second one says negative 2 greatest integer x. What do you think the negative is going to do to my graph? It's going to flip it. It's going to reflect it. Make it drop instead of rise. There it is. It's the green one. We missed out on the drama because the calculator did stuff after it shut down. But there you can see it. So the numbers that are in front of your greatest integer notation will make the graph steps increase or decrease. And the coefficient of x will take the step and either lengthen it or shorten it. Okay? All right, so let's go back now and talk about some more information. Let's define what the greatest integer function is. So it says this, the f of x is equal to, and you have this double bracket thing right here that says the greatest integer of x. So there's the notation. Learn it, recognize it. Now let's figure out what it means. So you have this function of the greatest integer of x, whose, I didn't mean to write whose, I meant to write where. I can't read my own handwriting. Where the value of y, or f of x, as you know, that corresponds to x is the greatest integer that is less than or equal to x. In short, you must round to the less than, so you're going to always be rounding down, always, regardless, even if it's closer to round up. Resist the urge to round up. If you've got a part of a number, it doesn't count. You have to throw it away. It's not it's not an integer. You have to drop it. It's no good. Okay? So here we have the parent function and a couple of practices just to see if you can visualize. So I have for the f of x is equal to the greatest integer of x. Find the f of negative 2 71/100. Okay, you're in negative land here. So if I were to ask you to graph that, here's negative 3, here's negative 2, and negative 2.71, or 2 71/100, it's right there. I have to round it down. So it is negative 3. I can't round it up to negative 2. Remember, when you're in negative land, everything's backwards. Okay? So can you visualize the function of a negative 23 2/3? Round it down. Negative 24. Again, if you have to visualize it, okay, here's negative 23, here's negative 24, negative 23 2/3 is right there. Round down. Okay, let's look at C. The f of 4 99/100. Yeah, you want to round it to 5, huh? Right? You have to fight it. Fight, fight, fight. This is not a ceiling function. We don't round up. This is a floor function. We round down. Okay, how about the f of 10? It's 10. You know why? Because it can equal x. It can equal x or it can be less than x, but it can't be bigger than x. Never, never, never. Okay, so that's the concept of the greatest integer. It's the closest integer that is below your x, that whatever x you pick. Okay, so here are some helpful hints for graphing. If you're just trying to get through it and you want this extra tip. So I have a format here that says if I have the f of x is equal to some number a times the greatest integer of some number b times x, and I don't have the h and k in there, which we usually have. I'm not worried about that right now, just because the a and the b really tell you a lot of things. Okay, a tells us two things. If a is positive, this graph will step up because it's positive. So it's going to be an increasing function. Step up, a units or a integers. Whatever it is, that's your step. It tells you which direction to step, and it tells you how high to step. Okay? And the reciprocal of b, which is 1 over b, by the way, the reciprocal of b, sometimes it's 1/3, so you flip it over to 3 over 1, tells us the interval length. In other words, how wide is the step length. So the a tells us how high the steps have to be apart, or how far apart the steps are, and the b tells us, well, the reciprocal b tells us how wide the steps are. So they're really important numbers. Otherwise, this is a really tedious process. Okay, so if you are ready, here we go. I have started with the parent function. The f of x is equal to the greatest integer of x. And let's talk about what our domain is. Our domain is the set of x's that I can use. Is there any number that I'm not allowed to put inside a greatest integer? I can put anything I want in there, right? So my domain is from -infinity to infinity. I can pick any number in the whole number line on my domain. So I'm going to graph all the x's, all of them. Every x in between all the numbers, every x. But what about my range? Can I get numbers, all the numbers? No, just the integers. And I can't really write that in interval notation, so my range is just the set of integers. Okay, so there we have that. Let's identify the a, the imaginary, not imaginary, but this invisible a right here. What is it? Right here. It's a 1. 1 times. Okay, so there's that. A is 1. And then a reciprocal of b. The b is the coefficient of 1, the number here. 1 over 1, which is just 1. And that's really great information. It gives us a lot to work with. So does this graph step up or down based on your a? It's positive, so it goes up. And what is my step height? What's my a? It's 1. So we're going to be going up 1 unit, or in other words, 1 integer. So we're going to be stepping up 1 integer, and then when we reverse it, we'll step down 1 integer to go to the other side of the graph. Okay, so we have our a is helping us do things. Let's look at our b. Our b. So what's our step length or our interval length? 1 unit. All right, so in order to graph anything, we always have to have a starting point. So I say we go and we find our starting point. Now, in the past, I'm going to just remind you of a couple things. If I were to ask you to say, to graph y equals the square root of x minus 2 minus 3, to start this out, I would always tell you to zero out, right? So x minus 2 equals 0, x equals 2. Okay, so I know that that's part of my starting point. And then I actually plug a 2 in so that I can find my y, right? So we always learn to do that. So y is equal to square root of 2 minus 3. This is 0. So what's my output? So we can still use that same strategy to graph greatest integer functions. This strategy works pretty much for all. Well, if they're written in a nice form. Maybe not if they're written in standard form. These aren't in standard form. Okay, so let's do our starting point. So let's zero out. So we have the f of x is equal to the greatest integer of x. And let's zero out what's in our greatest integer symbol. So that's x equals 0. So I know I'm going to start at 0. I just now have to plug a 0 into my function. So the function of 0 is equal to the greatest integer of 0. 0 rounds down to 0. So I know that 0, 0 is my starting length. So I'm going to come over to my graph. And you know what? I'm going to have you do your graph. Let's change the scale to make every other step a step of 1. So let's go 1, 2, 3, 4. I think you guys goes to 5, right? You can go to 5. So make all of your steps, just change your scale a little bit so your graph isn't so tight. It's going to be hard to see. I couldn't find a really nice graph yesterday. My computer was acting up. Okay, all right. So we've got that taken care of. I want to give you enough time to do that. Okay. So now I really have to focus on my B term. So I'm going to give you some instructions. Now I feel like I have enough information to just graph this right now, but we're going to go through the process every single step really in detail. Okay, so I know that my interval length is 1. So if I start at 0, I can extend all the way out to 1 because that's an interval length. That's the interval in the domain from 0 to 1. But here's the thing. I cannot include 1 because if I include 1, what happens if I put a 1 inside my greatest integer? Does it equal 0? No. So we are going to do a whole step of 1 unit, but we're not going to include 1 because 1 will push it to the next integer. So my advice for you here is to pick a number that's in your interval. Any number between 0 and 1 would work. Half? Okay, so half. So the greatest integer of half, what does that round down to? 0. We knew it was 0, 0. Okay, so that's good information. So guys, here's the thing. On the x-axis, this is your interval length. On the y-axis is your interval jump, height. And it's going up 1. As I go right 1, it goes up 1. Let's just do, so I know that from 0 to 1 on my graph, all of these numbers, do you guys agree that 0.75 rounds down to 0? Okay, so what you're going to do is you're just going to fill in that spot. But when you get to 1, you're only going to approach it. So open it up. So tell me to approach 1, but not include it. Okay, so now what we're going to do is we're going to go back to our table of values, and we're going to pick the next interval. So the next interval would start where we left off, inclusive 1, all the way to non-inclusive. And then we can pick any value we want within that domain interval. So 0.75? 1.75. Okay, 1.75 will work. 1.75 rounds down to 1. That's the nearest interval. So I know at 1, 1, all the way to 2, 1. So I go up to 1, 1, fill it in, stretch it a unit long, open it up. And that's really enough to give you the pattern that's going to continue. This graph isn't going to change. So hop up 1 whole unit, fill it in, stretch it out, and then open it up after the unit. Do 1 more, step it up 1, fill it in, stretch it out for 1 whole unit, and then open it up. And it would continue, and mine's going to continue off of my graph. I would really like you to get at least 6 steps in there, or if the steps are really long, you might only get 3. Let's reverse it though, so you know how to reverse it. So back to your starting point, drop 1, open it up, and reverse. Go backwards a unit, fill it in, drop it down 1, open it up. You got it, right? So I'm going to shut up, or I'm going to stop talking so that you can get it done. And there you have what we call a greatest integer function, or a step function. It is discontinuous. See the breaks in the graph. It's not a continuous graph. You have to actually pick up your pencil off the paper to move to another position. Okay, questions about that before we move on to the next one? We're good? Oh, wow. Well, okay. That makes me happy. Here we go. So here we have another one. It's got a little bit of a tweak to it. It's the f of x is equal to the greatest integer 1/3 x. Is there anything I am restricted from my domain? No. Nope, negative infinity to infinity. How about my range? I'm restricted to only the integer set. That's all I can have. Because it's a greatest integer function, I can only get out whole numbers and their negative counterparts. Okay, so let's identify our A. That's this invisible number here, right here, 1. And the reciprocal of B, look here, 1/3, it's 3. Flip it over, 3/1, or 3. Okay, so that tells us some good information. So let's focus on our A. Is it going to step up or down? It's positive, up. And how high is each step going to be? 1 unit, high. So each unit's going to step up 1 integer. It's going to go up 1 integer, up 1 integer, up 1 integer. What's our step interval length? 3 units. Okay, let's talk about y really quickly, or maybe not so quickly. Why is it 3? Let's get our starting point first. Let's figure out why it's a unit, 3 units long. So we'll start with our starting point. So we have the f of x is equal to the greatest integer of 1/3 x. And we're going to zero out what's in our greatest integer. So 1/3 times what equals 0? Isn't it 0? Because you just clear the fraction, you know, multiply both sides times 3. There you go. Okay, so x equals 0. And if I plug in a 0, what is 1/3 times 0? 0. So my output would also be 0. So I know that I'm going to be graphing 0, 0. I'm going to start a step right there. But let's talk about why this step is actually 3 units long. Okay, so let's plug in another number in this units, because I say it's going to stop right there at 3. So just watch. So pick a number in there. Okay, so if I do the f of 2, that is the greatest integer of 1/3 times 2, which is 2/3, and 2/3 rounds down to 2/3. Rounds down to 0. 2/3 down to 0. Okay, so even here at 2, I'm still rounding down to 0 because each number is 1/3 of the whole. So if I do 1, what's 1/3 of 1? 1/3 times 1? 1/3. What's that round down to? 0. But if I plug in a 3, 1/3 times 3. What's 1/3 of 3? 1. What's the greatest integer of 1? So at exactly 3, my integer jumps to the next one up. So there's the reasoning there behind why my interval is 3 units long. So let me just erase this so I don't erase everything. Scoot that back out of the way. Okay, so we're going to come over here and do our intervals real quick. So we're going to start with 0 as the starting step, and it's going to extend out 3 spaces, so we're going to approach 3. Okay, and then you tell me what number in there you wanted. We did 2/3, right? So we'll just pick a 2, plug in a 2. So 1/3, I'm going to rearrange this, that's too messy. So the greatest integer of 1/3 times 2 is 2/3. That rounds down to 0. So all the numbers between 0 and 3 on the x will round down to 0 on my y. So there we have it. Okay. So what's our next interval starting at? We're picking up at 3. We're extending out to 6 because it's 3 units long. And we pick any number we want in there. Whole numbers are nice. So how about 4? Okay, I like 4. So 1/3 of 4 is 4/3, or 1 1/3, which rounds down to 1. So you can see right here your step height. What happened when I went right 3? I went up 1. So I go to 3, 1, and started out 4, 1, 5, 1, 6 would give me 2. So I'm going to just do a step there. Closed on that. And that's enough to get your pattern. Then you just continue. So from the 6, you're going to go up 1, fill it in, extend out 3, stop. Then back it up. Go back to your origin and reverse. Down 1, open it up, back 3. Down 1, open it up, back 3. Down 1, open it up, back 3. And there you have that step function. And because your coefficient of x was 1/3, the steps got really wide. They had to go 3 steps over to go 1 step up. Questions? Yes. What's that? Which values? These numbers? Mess. So let's go through this and see if you've caught on. We already know our domain and range, right? Negative infinity to infinity, and our range is integers. What's our A term? Look. -1. See it right there? Reciprocal of B, 1/2. Those are baby steps, skinny steps. So let's go and do units jumping by 4. So go over 4, that's 1, over 4, that's 2. And this is going to be enough to get what we need. Quickly. Okay. So since our A is negative, are we stepping up or down? How much? 1. It's still 1. It's just step down 1. What's our interval length? We've already determined it. Look, it's 1/2. Okay, so really quickly, we just need to know where to start. So I'm going to start by zeroing out what's in my greatest integer, which is, so what would zero that out? What would x have to be? X has to be 0. So if I plug that in, the f of 0 is equal to the opposite of the greatest integer of 2 times 0 plus 1. What am I going to get out of that? That's the greatest integer of 0, which is 0. 0 plus 1 is 1. So I know I'm going to go to 0, 1, and I'm going to start right there. Okay, so that's a starting point. I'm not even going to fill out my table of values. What's my interval length? 1/2 unit. So I'm going to stretch to 1/2 and open it up. Now I'm just going to step up or down, down. So I'm going to drop a whole unit. Let's finish it. Put a point, step a half over, open it up. Okay? And then it would continue on. So for homework, finish up that graph. Also, okay, so we started graphing that, and I'm sorry I had to pause the video. And so that was for our integer when we had our x was 0. I'm going to erase a little bit of this work so I can show you what we're talking about. All right, so we had a starting point where with x was 0, our y was 1, and our step interval length, which is our x length, is a half. So this interval is going to be a half a unit long, approaching half. So you could do things like plug in an alternate value here, or a value that lives within this domain. So you could pick 1/4, and then that lives between 0 and 1/2, and plug it in. So that would be the opposite of 2/4, which is 1/2. 1/2 rounds down. The greatest integer rounds down to 0. The opposite of 0 is 0, and 0 plus 1 is 1. So you can see that. Right? So we would go up to the next interval, which would start at half, and it would approach 1, because the interval again is a half unit long, and you could pick any value within that set. So you could pick 3/4. Excuse me. Plug that in and then add 1. So that would be 6/4, or 1 and 1/2. 1 and 1/2 rounds down to 1. The opposite of 1 is -1. Let's just take that math again. I'm sorry, let me back that up. 2 times 3/4 is 6/4, which is the same as 3/2, or 1 and 1/2. So the greatest integer of 1 and 1/2 is 1, and the opposite of 1 is -1, and -1 plus 1 is 0. So you can see that between the integer, or the interval of half, all the way to 1 on your x, your output is 0. And that gives you enough information to continue on that pattern. It's got a drop of 1. So we drop 1, fill it in, go over to interval half of it, half a unit, and then open it up, drop 1, and scoot over a half. And then you can reverse it, of course, up 1, open it, and move to the left. And you're off. I'm off my graph. Anyway, sorry about the messiness of that specific slide with everything being interrupted. Okay, last one here quickly. This is such a long video. Okay, so here we have a function of x is equal to the negative greatest integer of x plus 2 minus 1. Domain and range remain the same as always, where a is -1. The reciprocal of b, which is right here, is 1/1. This is going to step down, according to our a, at a unit of 1. Excuse me. Our interval length, based on our b, is 1 unit. Okay, so now what we need to do is just find our starting point by zeroing out what's in our greatest integer symbols. So we'll take x plus 2, set it equal to 0, x equals -2, and then we'll plug it back in to find the output. So we're going to go the opposite of the greatest integer, -2 plus 2, close that, minus 1. This is 0, so it's the opposite of 0 minus 1, which is -1. So I get a starting point, excuse me, a starting point of -2, and then my output is 1. So now we just need to determine what our interval length is. It's 1 unit, so that would be from -2 to -1 approaching. And then, of course, you can plug all of that in and you would see you can pick a number between them. Like, for example, negative 1.5 plus 2 minus 1. That would give you, when you do that math there, 1.5 plus 2, negative 1.5 plus 2 is 0.5. And that rounds down to 0 according to your greatest integer. The opposite is 0, 0. 0 minus 1 is negative 1. Okay, so I'm going to go to my x-axis to negative 2 and down 1. And I'm going to put a point, and then I'm going to reach over to negative 1 and open that up, approaching 1. We'll do our next, I'm going to erase a little space here so I have some space. We're going to pick the next interval up. So we're going to start with negative 1, and we're going to run all the way to 0. That's another unit, step length of 1 unit. Plugging that in. So a negative 1 plus 2 minus 1. Greatest integer, that's 1. Greatest integer of 1 is 1. The opposite of 1 is negative 1. Negative 1 minus 1 is negative 2. So I can go to negative 1, negative 2. Negative 1, sorry. Negative 1, negative 2. And I'm going to extend this all the way out to 0, approaching. And that's enough to see the pattern, and you can just continue. And there you have it. The homework is to do problems 41 through, 44, and summarize your notes. Sorry about the mess ups in the video. Have a good one.